So today we're going to be taking a look at a few of the questions for the upcoming test. Now the questions that were selected by your classmates are questions 1, 2, 3, and 7. So we're going to go over those 4 problems together. To start out, let's go ahead and take a look at question 1. So question 1 says simplify the expression. So what we're going to do here is we're just going to simplify this as much as possible. Go through any order operations, PEMDAS, and just basically work it down from there. So the first thing that I see is I do see a set of parentheses. I'm going to look inside there, and I can't simplify anything on the inside. So my next step is to move into exponents. Again, I can't do that, but I can do multiplication and division, which means that this 4x can be multiplied in to both of these terms, along with, separately, this negative 5 can be distributed into both of these terms. So let's go ahead and distribute those aspects. So 4x times negative 2 is going to become negative 8x. And then 4x times 3x is going to become a positive 12x squared. Likewise, the negative 5 times the x is going to become a negative 5x. The negative 5 times the negative 7x squared is going to become a positive 35x squared. Now at this point, all we're going to do is we're going to go ahead and we're going to combine like terms. The first thing I see is I see a positive 12x squared and a positive 35x squared. I'm going to combine those into 47x squared. Next up, what I see is I see a negative 8x and a negative 5x. I'm going to combine those to make a negative 13x. At this point, nothing left to do. There we go. Perfect. Now let's move on to number 2. So number 2 says solve the equation. So let's take a look at this one. Now with this one, unlike where we're using order of operations to condense an expression, we can do that, but when we condense an equation, we're going to look at it from a left and right side. So the first thing that I'm going to do is do exactly what we did, but only to one side of the equation. So let's take a look. I'm going to go ahead and I'm going to distribute this 5 to both these terms. So 5 times 1 is going to give me a 5. 5 times 4m is going to give me a 20m. And I'm going to leave the minus 2m. The next thing that I'm going to do is I'm going to combine my like terms. Right here I have the 20m and the negative 2m. When I combine those, let's do this in blue. 20 minus 2 is going to give us a positive 18m. And just like before, because I didn't do anything with the 5, I'm going to leave the 5. And because nothing over here can be simplified any further, I'm going to take a look at the other side, negative 13. Nothing's going to happen over there, so I'm going to drag that all the way down. So equals negative 13 equals negative 13. I have this. Now, when I start moving things to the other side of the equation, I'm going to be canceling them out over here. So in essence, I'm going to look over here and say, what do I need to get rid of to isolate this m? Well, I have a 5. Let's go ahead and take away the 5. So minus 5. Now, I want to be even between the two sides. So if I take away 5 on the right, I also have to take away 5 on the left. So let's take away 5 over here. Perfect. So that's going to say that 5, in essence, cancels out. So I'm going to be left with over here on the left, negative 13 minus 5 is going to be negative 18. And over here I have an 18m. Let's rewrite that up here to get some more room. So we have negative 18 equals 18m. Okay. Again, I'm only going to be looking at the right-hand side. What do I need to get rid of to isolate this m? Well, I have an 18, and that 18 we know is intuitively connected with multiplication, so I'm going to go ahead and divide that away, which means over here I divide it away by 18 as well. That in effect cancels out the 18, and I'm going to be left with m equals negative 1. There we go. So that's number 1 and number 2. Let's take a look at the third one. So the third one says write an equation and then solve. Now this one does contain a small error on my behalf. The one I was writing the problem, Clayton, this good old boy, is going to end up with a negative age. So let's just say that Clayton is the unborn child that your parents are planning on having, but they haven't quite decided on a time to go for yet. We're going to ignore that and we're going to solve this as it is. So let's read through this. Richard is twice the sum of the ages of both Clayton and Michael. If Richard is 66 and Michael is 38, How old is Clayton? So let's set this up as we would set up an equation. So the first thing I know is Richard is. So that typically means that if Richard is represented by R, is going to be our equal sign. Is going to separate left from right. Twice the sum. Okay, so what am I taking the sum of? The sum of the ages of Michael and Clayton. So if I sum the ages of Michael and Clayton, this means addition. And I'm going to take these two things. If I'm adding Michael and Clayton, let's take that and put that in here. So R equals, just move this down to give us more room. So I'm going to take Michael and Clayton and I'm going to add them together. The last thing that I'm going to do is twice. This means multiply by 2. And so I'm going to take the sum and I'm quite literally just going to multiply it by 2. So there's my equation, part 1. The second part is, how old is Clayton? Okay, well, let's plug in what we know. Here I know that Richard is 66 and Michael is 38. Okay, so let's just plug those variables into what we know. So for R, I'm going to take 66 equals 2 times Michael's age is 38. So 38 plus Clayton's age. Okay. And now we're going to go through and we're going to solve this equation. So again, I'm going to do my best to isolate the right, and I'm going to simplify this as best I can. Now, when I simplify this, what I'm going to do is I'm going to distribute my 2. 2 times 38, 2 times 30 is 60. 2 times 8 is 16. 60 and 16 makes 76. And then I'm going to have a 2c. I can't simplify this any further, so I'm just going to go ahead and check out what's left in the equation. Equals to 66. Perfect. Next thing I'm going to do is I'm going to go through and I'm going to isolate this. I need to get rid of the 76, which means I subtract 76. And we see where our first issue comes up. Because as of right now, I've entered into the -10 category. Drag this right here to give us some more room. So I have -10 is equal to 2 times Clayton's age. And if I look at the last little piece of this, I know that in order to get rid of this implied 2 times c, what I need to do, I need to divide by 2, which is going to give me Clayton must be -5. So I'm going to put Clayton will be born in 5 years. Again, that's an error on my behalf when I made the problem. So we answered it, we came to a conclusion. The answer doesn't really make sense, but we're going to go with it. Perfect, so that's number 3. And the last one that we're going to be looking at is going to be number 7. So number 7 says, solve the equation. Right here, it looks like we have absolute value brackets. So our goal with absolute value brackets is to isolate what's inside these brackets. So the way that I'm going to look at it is I'm going to look at this as box. Okay, so how do I isolate this box? Well, let's look at this side of the equation. What is outside of my box? A -5. So how do I get rid of the -5? Well, I know that this -5 is connected with multiplication. So what I'm going to do is I'm going to divide this left-hand side and the right-hand side by -5. So that will, in essence, cancel out this. And if I do that over here, let's see what we get with. Separate my steps. So I'm left with absolute value of 3 plus 4k. And absolute value is equal to, let's see, 5 fits into 120 times plus an additional 3, 23. Perfect. So now I'm going to take this and I'm going to keep working. But now that I've isolated my box, my absolute value brackets, I can split this. So come down from the top. And I'm going to take my leftward and my rightward direction on the number line. With absolute value, remember, I can look absolute value to the left or the absolute value to the right on the number line, and they're the same distance away from my central point. So I look to the left and to the right by multiplying by a -1 and a +1. I'm going to copy down what's in my box. So 3 plus 4k. 3 plus 4k. And then I'm going to take this right here and say, well, 23 times negative 1 is negative 23. 23 times positive 1 is just regular old 23. Awesome. Now for this, I'm going to go through and I'm going to solve the two equations. First thing is subtract 3. That's going to give me a 4k is equal to negative 26. Now I'm going to go ahead and divide by 4. Unfortunately, 26 doesn't divide by 4, but it does reduce. So both the top and the bottom are divisible by 2, so that's going to give me negative 13 halves. Awesome. So that's answer number 1. Answer number 2, let's work this one. So I'm going to take this and subtract 3. That's going to leave me with 4k is equal to 20. The next step is I divide by 4, and I get k is equal to 5. That's answer number 2. Now the second thing to remember with absolute value is always when you get your two answers, we always have to double check to make sure it works in the original, because these might be extraneous solutions. So my last step of this, and let's do this in green, is I'm going to copy down my original equation, but I'm going to plug in my two variables and see if they confirm or deny these as working answers. So let's see, I have a negative 5, absolute value of 3 plus 4 times the number is equal to negative 115. Negative 5 times the absolute value of 3 plus 4 times the number is equal to negative 115. Let's make this bigger because I'm not going to notice that double 1. And what I'm going to plug in is negative 13 halves. Negative 13 halves, and I'm going to plug in a 5. And let's work this out and see where we go. So first off, 4 times a half is going to be, so 4 divided by 2 is 2 times negative 13 is negative 26. So 3 plus a negative 26. Negative 5 equals negative 115. 3 minus 26 is going to be negative 23. Absolute value is positive, so negative 5 times, that is now just a regular parenthesis because it is now a positive 23. Negative 115. 5 times 20 is 100. 5 times 3 is 15, so negative 115 equals negative 115. The first answer checks out. Second answer, let's see, that's going to be 3 plus 20 equals negative 115. It's going to be negative 5 is the absolute value of 23, negative 115, which we know that's going to be a positive 23, 115, which gives us a negative 115 equals negative 115. So both answers work out. Awesome. So I hope that helps, and best of luck on the upcoming test. There you go.